Ladies and gentlemen of Algebra 2B, welcome to Unit 9. Now we're moving right along. Talking about rationals. Rationals are going to be different than radicals, which you just got done with. Rationals are talking about what is, these are about as complicated as you get, so you got to be able to handle these. So let's get right into it. So the goodie shop sells candy and nuts by the pound. One item is a mixture with 8 pounds of peanuts and 5 pounds of cashews. Therefore, 8 over 8 plus 5, or 8 over 13 of the mixtures is peanuts. If the store manager adds an additional X pounds of peanuts to the mixture, write a new ratio to show what portion of the mix is peanuts. So if this is the original portion, and you're going to add X peanuts, so it would be X, 8 plus X on the top, but then underneath you would also add X, because X is going to be your pounds in peanuts. So, rational expression is a ratio of two polynomial expressions, basically a fraction or division problem of rationals where both the top and bottom are rational numbers. Multiplying, just like multiplying fractions, top times top, bottom times bottom. And then for dividing, you basically flip the second rational expression and then multiply. So, factor everything you can, simplify, perform the operation, then factor and simplify again if it's possible. So that's kind of your four-step process. Factor everything you can, simplify, perform the operation, and factor. So here, factor everything you can. So if I've got 4a 5b times 15b squared, 16a to the third, that's a 2. So I'm going to simplify everything I can before I actually do the operation. So a over a to the third makes that a squared. B underneath b squared gets rid of that, so it's just b to the first. Now, if I can think ahead a little bit, I can simplify some of the numbers too. So 4 and 16 becomes 1 over 4. 15 over 5 becomes 3 over 1. So on the top I've got 1 times 3 times b. So on the top I've got 3b. On the bottom I've got 1 times 4a squared, so that's going to be 4a squared. So there is my simplified rational expression. And that's it. These are not too bad, strictly because they're all monomials. They're all technically one term. So here, since it's division, I'm going to flip it, flip the second one, and then kind of do what I was doing before. So start playing around with what I can cancel out if it's possible. So x squared over x. So if I've got, so I've got x squared and x. So that'll cancel out, that'll cancel out. For y, I've got y over y squared, so that'll cancel out, that'll cancel out. I've got a up here and a to the third, that'll become a squared. B is interesting because b completely goes away. B cancels out because it's b to the third over b to the third. So now I can actually get into the numbers. 4 over 2 is just 2, and 15 and 5 can simplify to 1/3. So on the top I've got 2, I've got x, and nothing over here. So that's just going to be 2x. On the bottom I've got 3a squared y. So that would be my answer, 2x over 3a squared y. Double check, don't forget this fourth step. If you can keep simplifying or factoring some more, do it. You'll never know what more can cancel out there. So all I did was a lot of stuff ahead of time to cancel out my variables and my numbers, simplify my numbers. So here, let's see what this is going to bring. So 8m squared n, 5r squared, 15nr, 12m to the third n squared. So now this one's going to be a little bit trickier. Let's start with this. M squared and m to the third. That will completely cancel out. 2 of the m's will cancel out, so I'll be left with just m. Now if you look for the n's, so I've got an n here and an n here and an n squared. Well, n squared is going to be n times n. So the n's completely go away. Now for the r's, so for the r's, I've got an r up here and an r down here. Let's switch colors. So that's going to cancel out. I'll be left with just r. So now look at numbers. Numbers. So 8 over 12 is going to be 2 over 3. 15 over 5 would be 3 over 1. So on the top, I've got 2 times 3, which is going to be 6. On the bottom, I've got 1 times 3m. But now I missed something here because I can keep simplifying. So 6 over 3 would be 2. So my actual simplified answer is going to be 2 over m. Now another way to do it, completely break everything apart and cancel it out that way. That's just kind of some examples of what's going on. So here, let's take a look. So if I go 18 ab squared 25 x squared y cubed times 10xy over 9b. One step that might help you guys if you're struggling with this so far is just to write everything on one fraction and then just kind of put things together. So you have 25, 9, I got a b, I've got x squared, we got y cubed. So just kind of line everything up and then see what you can cancel out from there. So that's 25. So 18 and 9 becomes 2. Okay, 10 and 25 can both be divided by 5, so that becomes 2. That becomes 5. A and nothing, b squared and b squared and b, so that would cancel out, that would cancel out. X and x squared, that would cancel out, that would cancel out. I would be left with x. And then y over y cubed, that would cancel out. This would become 2. So after all that noise, my answer would become 4ab over 5xy squared. Again, all I did was put everything on one line just to make life easier on myself. So same idea, keep working with this. This one actually gets pretty clever too because of just the way that's set up. So if I go I can put things together, I can keep it, if I want to think about it, oh, it's multiplication, so it's all over one line. I can do that too. Multiply here, multiply here. So 9 and 27 would become 1 over 3. 8 over 16 would become 1 over 2. Now I can start looking at the letters. So let's look at m. Well, I've got m squared here and m to the 5th. So that'll completely go away. 2 m's away from the bottom becomes m to the 3rd. N to the 3rd and n, that would cancel out. That is no longer n to the 3rd. That is now n squared. Now if I look at the a's, a squared and a, that would cancel out. That would cancel out. I'd be left with just a. B would cancel out. Now b is just left to the 3rd. So on the top, looking along, I don't have a lot. I've got n squared times a. On the bottom, I've got 2 times 3, so that would be 6. B to the 3rd, m to the 3rd. That's as far as I can go with that one. So same kind of idea. Hopefully you guys are starting to get the hang of this. So start looking at what can I cancel out. Well, I'll go numbers this time first. 14 over 21 becomes 2 over 3. 15 and 35 can both be divided by 5, so that will be 3 and 7. Start looking at W's. That goes away. The W to 3, W to 7th. This becomes W to the 4th. P and Q, well, that P goes away. This P now becomes P squared. Let's change colors here just for sake of not confusing. Q goes away. This Q just becomes Q. Z now becomes, well, that Z third goes away. Instead of Z to the 8th, that now becomes Z to the 5th. So on the top, I'm left with 14Q Z to the 5th. On the bottom, 3 times 3 is 9W to the 4th P squared. So you got to be very strong with simplifying and very, very strong with exponent division there. So factoring. Please remember factoring. Please remember factoring. We've only done it 11 billion times. So what multiplies to 12 adds up to negative 4. X minus 8. X, or not 8. Where am I going with that? Not 8. How about 6 and positive 2? How about x plus 2? X plus 1. Here, factoring out of 4x squared, I'll be left with x plus 3. So, first rule of factoring is always pull out what's in common. So that's what I did on that one. This one, some of you guys might draw your x. That's fine. But I'd like you to start being better at just recognizing factors. So, now the game gets up a little bit. So now life gets a little more complicated. These are no longer just single things, okay? They're no longer monomials. Now I've got binomials, trinomials, all sorts of things. So what I've got to do is factor here. So this first part becomes x plus 4, x minus 2. On the bottom, that's going to be x plus 3, x plus 1, times, and then if I factor this out, 3, x plus 1, x minus 2. So now I'm going to start canceling things if I can. So I've got x plus 1, x plus 1, x minus 2, x minus 2. This 3 and this 3 I cannot cancel out because this 3 is part of x plus 3. All I'm left with is this, 3, x plus 4, x plus 3 on the bottom. Now, one thing that I haven't mentioned that I'm going to now, and it's going to become pretty important, is these are all rational expressions, but they're also fractions, and in fractions, I can never have anything divided by 0. Cannot do that. So, if there's any situation where my denominator could possibly be 0, I have to say, you know what, this x cannot equal this thing. So here, I cannot say, I've got to say x plus 3 cannot equal 0, so x cannot equal negative 3. So that's called kind of my rule. That's kind of my limitation. You know, here's my simplified answer, but x can't equal negative 3. So, same kind of idea here. Factor simplify, do the operation. So this, x plus 2, x plus 3, times x plus 3, x minus 3. Notice I went from bottom to top, top to bottom. Now I start canceling out what you can. So I got x minus 3, x minus 3, x plus 3, x plus 3. I am left with x plus 2 over x plus 4. Do not take this and think that you can say, oh, that's 1 over 2. No, that's wrong. The 2 is with the x here, and this 4 is with this x here. So this is my answer. But I do need to say x plus 4 cannot equal 0, so x cannot equal negative 4. Get in that habit of telling me, here's my answer, here's my exclusion. So again, just kind of running through some of these. Y minus 1, 5, and then I pull out what's in common, get y plus 3. That'll be y plus 3 y plus 2 on the top. On the bottom, y plus 5, y minus 1. Factor, 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 factor. I told you many times you got to be fast at this. Cancel, 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 cancel. I'm left with y plus 2 on the top, 5, y plus 5 on the bottom. And again, y plus 5 cannot equal 0, so y cannot equal negative 5. There's my exclusion. I have to bring this part along, all right, otherwise I'm technically not correct. So again, x plus 7, x minus 5, x plus 2, x minus 2, that's a difference of 2 squares. Then I move the second part. So start canceling out. Boom, 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 boom. So I'm left x plus 7 on top, x minus 2 on the bottom. Can't equal 0, so x cannot equal 2. Don't forget your exclusions, otherwise you're wrong. So if I have a complex fraction, I'm going to multiply by the reciprocal of the denominator. So if I have this, I'm going to multiply both the top and bottom by the bottom. So I'm going to go here, cancel, 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 cancel. So this whole bottom thing cancels. I will have, I can't even cancel this. So after all that noise, I get x squared plus 1 over 3. There's my answer. So if I look, it's like a huge division problem. So all I end up doing is taking x squared, then x squared minus 25y squared. And I end up multiplying by the reciprocal of the bottom. So it becomes x minus 5y over x. Multiply that. X minus 5y. So I can factor this guy down here. This is actually x minus 5y, x plus 5y. So that'll cancel, that'll cancel. One of the x's will cancel out with this. So I'm actually left with x over x plus 5y. And again, x plus 5y can't equal 0. So x can't equal negative 5y, things like that. All right? So same idea. So let me write this. X plus 3 squared. X squared minus 16 is nothing more than x plus 4, x minus 4. Then I'm multiplying by the reciprocal of the bottom. So I'm going x plus 4 over x plus 3. So that's what I'm going to multiply by. X plus 4 over x plus 3. So, looking around, x plus 3 squared technically means that this is going to be x plus 3 times x plus 3. Cancel, cancel. X plus 4, cancel, x plus 4, cancel. I'm left with x plus 3 on the top, x minus 4 on the bottom. So x cannot equal 4. And there's my simplified solution. That's as far as I can go. All right, so don't forget geometry, never goes away. That is the area. That has got 3x minus 5. Determine the height of the parallelogram. So what I want to take is 6x squared minus 7x minus 5 divided by 3x minus 5. So my first attempt will be to factor this, and I can do that. That's going to be 2x. Be left with 3x minus 5 plus 1, 3x minus 5. 2x plus 1, 3x minus 5. Now, that's just the top. This still goes underneath of it. But now notice, that cancels, so I'm left with 2x plus 1. There's my answer. That is the height of this problem. All right, you have to be very picky about this, and you have to keep everything very detailed. Take your time and come talk to me with questions.